Let's go over how to do a moderately tough trig identity. Basic strategies always are start on the tougher side, do any obvious math, do any obvious trig, and keep trying. Looking at this trig equation, I would say this left side looks like a much bigger mess than the right side, so we should start on that. And just to illustrate my thing about try again, don't just keep looking at it thinking, because you could have the right answer under your fingertips and not see it. I'm going to show you something wrong that I tried. Well, first of all, I said 1 over tan x. That's cotangent x. So the numerator becomes cotangent plus cotangent, which is just 2 cotangent x. And for the denominator, that's cotangent x plus tan x. And then my first thought was, whoa, I'm a smart math cookie. I know that if I multiply both sides by cotangent x minus tan x over the same, I will get difference of squares, which will make cosine cotangent squared minus tan squared in the denominator. And I was thinking, and then great, I can use one of those Pythagorean identities. But then I remembered, oh, that's right. The one for cotangent has cosecant squared, and the one for tangent squared has secant squared. They don't really simplify each other out. So I erased that. I said, all right, I tried it and it didn't work. So what next? Well, the next thing on my list of things to try is to look for any obvious math. And one thing I notice is that this up here is a complex fraction. And so if you see such a thing as a complex fraction, you should simplify it. And so I'm going to go back to this one up here, except I am going to leave that 2 cotangent x that I got in the numerator. But for the denominator, I am going to do my best to give that denominator an LCD and turn it into a single fraction. So 1 over tan, and then tan x becomes tan squared over tan. And so we really have 2 cotangent x all over 1 plus tan squared x over tan x. And then the next thing you do to get rid of a complex fraction is flip the second and multiply. Remember that? So we have 2 cotangent x over 1 times tan x all over 1 plus tan squared. And now we're starting to see the light, because remember before when I wanted to use a Pythagorean identity, and usually that's a good idea. What I did to try and find a Pythagorean identity wasn't wasted time, but here's one that fell right into my lap. And 1 plus tan squared does work. That is secant squared. And furthermore, cotangent and tangent being reciprocals of each other, they just become a nice big 1. And so I have 2 secant squared of x, which is exactly where I was supposed to wind up.